So, I hope you're not getting tired because we are now going for some movement, motion, emotion. Um, we'll have movement on the computer screen. Let's see what I mean. Here you have Mario walking in Amsterdam. Now, I don't think that you can use Saxon-JS for first-class shooter or GTA-like game. But back in the 80s, I played Leisure Suit Larry, which was the last game that I ever played. And I think you could program that game with Saxon.js if you really wanted. So we saw this little man walking. Now let's see how this was programmed. The HTML file is in fact rather simple. We'll open it. It consists of a division with the ID Mario, and it has a background image which is Amsterdam. Also we specify the height of the division. Then inside the division is an image, also has an ID. This is the image. Note that it is a number. We have I believe 3 images, so they can be played after each other so that it appears as if the puppet is moving a bit. We set its height. The position is absolute, and the left, well, we'll change the value of left as Mario is walking from left to right. So how do we make him walk? And for this we have a new Saxon.js enhancement of XSLT. Here it is. We have some parameters in order, well, let's say some constants. Unlike otherwise, in the other style sheets, we use the initial template in order to make the movement start as soon as the page is loaded. By the way, this was also the case in the example with the moving mouse, but I forgot to tell you. So this is the usual construct of getting a reference to some HTML element. Here we get a reference to an image, and here is our magic weapon, IXSL schedule action. It schedules the execution of a template, named template. You see it being called here, which is the only content that schedule action can have, a call template. And it will execute the template after a certain time, and in this case wait time is 200 milliseconds. We pass it an iteration number. The iteration number will be used to calculate the position of the Mario image, and we start of course at 0. And we pass the image as a parameter. We could also have used a global parameter, but well, I chose otherwise. Don't know why. So now the move image template, which is, oops, that wasn't that great. Here is it. We see the parameters, of course. We calculate a new iteration, which is the old iteration plus 1. That's math that I am still following. And we also calculate a new image number, so Mario 1, Mario 2, Mario 3.png. And the image number is defined by the new iteration modulo the number of images, and then plus 1. It's some magic, and well, it works. We use this number to calculate the new path-3 image, new image source, and we have here some complicated search and replace operation, but it boils down to that we match here some numbers and we replace that numbers with the new image number. So if we have Mario 1, it gets replaced by Mario 2 and so on. Then we use IXSL attribute for the source attribute of the image, and we set it to this newly calculated source. And then we make it move. We set the style attribute, the left attribute of the style, and this is the iteration times the delta x, that is 5. So iteration 3, we will set the left value of the left attribute to 15 pixels for the image. So now we have moved Mario 15 pixels, or a number of pixels, to the right. And then we should prepare for the next iteration. And we do not iterate, we use recursion. But we don't want infinite recursion, so we do it only if our iteration is less or equal as the number of iterations, max iterations, 75. And then we schedule a new action. We schedule the same move image template recursively. We pass it the new iteration for the iteration parameter, and we pass the image. So, well, in fact, that's all there is. And I think you will be ready for your new challenge. This is, in fact, a challenge that requires a lot of code. The code is missing still, so you see this error message here. The idea is that you have to let this red rectangle move to the right slowly, and the blue rectangle to the left, so that in the end they have switched positions. You have the knowledge to do that because I explained you the moving Mario, but it may be a bit hard. So, well, if you don't want to do it yourself, you can open this XSLT and study it. Or if you want to do a bit of work, you can open this XSLT and supply the missing parts. Or you can decide to do it entirely on your own, and then you'll have somewhat more work. First, let us have a look at the HTML file, so that I can explain to you how it works, because it is not only HTML, it also contains some SVG. Let me show you. Here it is, and you see this SVG. Oxygen doesn't agree with it, but it's quite alright. Interesting part of this SVG are these two SVG rectangles. They have an ID rect1 and an ID rect2. They have an x coordinate. This one should be increased so that this rectangle moves to the right, and this one should be decreased so that it moves to the left. So I already said that I prepared the solutions for you. You find the solutions here. This one is the solution with fill in the blanks. I'll show you. Where it says your code here, you have to, well, of course, insert your code by understanding what the rest of the code does. If you want to see the real solution at work, this is your friend, because here it's solved. And if you want to do it on yourself entirely, then oh, this is not your friend, because I wanted to open the XSLT. This is an empty template. And oh, well, maybe I forgot to explain something. We have here a static variable debugging. Maybe it's relic, but let's see. Oh, this is the wrong style sheet. I'm blundering here. Yeah, I have this message to help you trace the movement, and if you set debugging to true, which it is not initially, you will see the messages in the JavaScript window, and otherwise this message is compiled out by Saxon-JS and you don't see any messages. So that's it. I wish you good luck.